exam tip, graphs should be, you should include all x-intercepts, all y-intercepts, unless they're not relevant to the problem. If you're solving by graphing and finding an intersection, it doesn't need that. But if it says sketch the graph, you should have that. Um, they expect you to use a ruler and draw, or some sort of straight edge, draw straight lines. Scales should be a problem. What? I guess, so you can use the edge of your calculator. Um, things should be drawn to scale if it says draw the graph. If you're solving by graphing, draw it decently. Make sure that any relevant points for solving are labeled. Points should be plotted accurately, joined in a straight line or smooth curve. Make a decent drawing. Label points. Label your axes. Label your intercepts. Okay. Okay, so we're going to graph this by showing the intercepts of the graph. So sketch the graph. So let's just graph it. And the function is x cubed plus 2x squared minus 5x minus 6. Plus 6. So double check. It's minus 6. Either way, we're going to have to adjust our window. You definitely should not draw this graph. You need to adjust menu, window. -10, -15. Okay, so this would be a good window. My y-intercept is 0, -6. Um, if it doesn't specify maxes and mins, you probably don't need to. Okay, yeah, that's what I thought. Like this is -3, 0. This is probably 1, 0, and that's or -1, 0, 2, 0, and 0, -6. Those are the things that should be included in your sketch. Let's see, does the book include anything else? No. If you have time, maxes and mins wouldn't hurt. But you probably won't have time on the exam. Make sure to write coordinates as coordinates. Um, that this is not a function, but you could be asked to sketch the graph. I don't agree with this guy. He thinks we should do everything on computers. I do not think that's the way to teach math, although I do think we should do some. Okay, function operations. What operation would this be?
Multiplication.
Just multiply the two functions together. Make sure you use parentheses. This is one that people get so wrong and they try to make it composition when it's not. These are not the same. Those are the basic operations. When we're doing these operations, the domain, let's talk about what this thing means. They're saying d of the function equals set braces x such that x is a real number. That's true for f, right?
Yeah, I feel like I sometimes figure out the notation like on the assignments because like that's just like
Yeah. You can say domain. This is what I would use because I like interval notation better. This is called set builder notation. You're allowed to use whichever one you want. It's just important that you can read all of them. So G has a domain in blue here, 0 to infinity. So the domain of any function involving the two is going to get the more restrictive domain. D intersection G. What is the domain of the sum different product? If it's a quotient, you would have to remove the 0 because you can't divide by 0. So here we've got some functions. They put them together in different ways and you get different things. Isn't this one lovely? Multiply by the reciprocal. And then they simplified it to, yeah, to that. When giving the domain though, x minus 1, x is not equal to -1 is now in the numerator. But it was originally in the denominator as part of G, so it's not in the finished domain.
um are we the x is not equal to 1 is part of the domain of f over g of x, but it wasn't a restriction on the domain when it was just g of x is what.
So it's not in the simplified version, it looks like it could be, but because it wasn't in the domain of G of X, it is not in the domain of F over G.
Even though it technically could be in the
And in this boxed function, yeah, it could be in there. But it was not in the original pieces, so it's not there. Okay.
like how'd you know that? Like if you were just given the function in the box, you wouldn't know that.
If you're just given the function in the box, it's in the domain. Because I'm given F and G and I'm asked to put them together, if it's not in either of those domains, it's not there. Yeah.
There's not like an asymptote there.
No, there shouldn't be an asymptote.
Yeah, that's what I was thinking.
Just a hole because it wasn't in the original domain.
Smart.
This is
I found that none of the roots were. But then I was researching last night, and I think the only way that you can find irrational roots or complex roots is using Newton's method, which is really tedious.
that sounds about right. Yeah.
So anyway, but you can remain it there and we'll show that all those roots are not valid.
Yeah, I'm like, that's
That's easy.
that's easy enough to do, but
Tedious also.
tedious, but not as tedious as Newton's anything. Yeah. So consider these functions, f plus g. Find the domain. Okay, the key is the domain. Yes. So this one is negative infinity to infinity. This one is negative infinity to 2
So bizarre.
to infinity. So the intersection is that. Correct? The intersection is where both of them are valid. This one is everything but 2, this one's everything, so. Now the difference, same thing. And they showed it in set builder notation. Okay, a small retail shop knows by experience they can sell 500 t-shirts each year. In addition to the price of t-shirts, they need to pay a fixed €5 whenever they order a new supply. To store t-shirts for a year costs the company €2. It costs potentially less if they do not have to keep it in store for a full year. Graph the annual cost ordering and storing t-shirts in terms of quantity they order in each shipment. So it costs them $5 per shipment, right? And $2 for each one to store. And they can sell up to 500.
This is negative. Also squared.
So let's write this in terms of separate functions. Orders cost them $5 an order, correct?
This is negative.
The order size is going to be 500 divided by X orders.
Why?
So let's say they make 10 orders. Order size is 500 over 10, so 50 per order. So that's the order cost. Storage cost is 2 times 500 divided by X.
But I thought it was $2 per t-shirt, not per order.
This is the number of t-shirts that they're storing.
So they'll be storing one shipment at a time.
Theoretically, I think so. So, oh, they're doing 5 times 500 over X. They order X t-shirts at a time.
Cause that'll be like profit or no.
So they're doing X. They're doing it the reverse way, but I'm doing it. So X t-shirts they order 500 over X is how many orders they'll make. If they order X t-shirts in a shipment, they only order the next shipment when they are running low on the amount they have. They on average have X over 2 in stock per day. That makes sense, right? You got half. So S of X is this is a very IB way to ask a question. 2 times X. So the cost is 2,500 over X plus X. And we get this. And you can kind of get a minimum somewhere around ordering about 50 at a time. So it's the red one is the combined.
Okay. That's confusing to me.
How they wrote the function or
Yeah.
The hard part on this one, this goes from super easy to very hard. So if we say X is the number of t-shirts in an order,
So like how they knew how to like honestly, the whole thing.
oh, how to combine them? That makes sense to me. So here, if X is the number of t-shirts in an order, f of X is 5 times 500 over X. If the storage,
So we're just combining cost of supplies with cost of storage.
mhm,
Okay.
and your cost of storage, you're assuming
That we're only storing one.
you're storing
order.
essentially half of them for the time between orders. I don't know why only half? Because we're gonna sell,
Size, which is 500. And we were only storing one order at a time.
so this is a store a t-shirt for a year costs the company €2, and it costs proportionally less if they do not have to keep it in the store the full year. I would assume we're going to make multiple orders a year, but I think it costs them $2 per between order, would be a better way of saying it. And the less you have, the less length you're storing it, the less you have to pay to store, right? It's a little bit weird, but
What
they're saying
came from?
they're saying on average, you store a t-shirt for half the time. Let's say you order every 2 months.
That.
It doesn't really. This is not a well-written.
Just know that.
So that's
Just know not a full year means half.
well, to store a shirt each year costs the company. This is the proportionally less than for a full year. Again, I think they're ordering. I don't think they're storing for a full year anyways.
I just don't understand where X over 2 came from. Like,
So X over 2. So if they order t-shirts, X t-shirts in each shipment, when running low, you order more. You on average have shirts in stock for X over 2 is the amount of time. You have half the shirts you've ordered in stock over the course of a year. Because some of them you sell right away, some of them you don't sell till the end.
yeah.
So if you order 50, on average, you're storing 25. Does that make sense? That's how they're getting it.
I just don't think I think that's like kind of a stretch. Like I don't understand how people are getting to, but that's okay.
It's approximating. That if you order 50 shirts at a time, on average, you have 25 in stock. So that's half of the shirts you ordered. So, and then all they did, simplify the functions and add them together. The shipment cost plus the storage cost. The graph of it's the red one. You'd probably want to minimize by finding the minimum. That makes sense. That was the entirety of this section. There'll probably be a couple of confusing word problems, and the rest of it'll just be these find the domains. Graph this function and make a nice sketch. And make sure to make your sketches in the way that IB wants them. Okay.